finding an equation from a sinusoidal graph. Now let's go the other way around. What if we're given the graph and we want to come up with the equation? Well, we can use a similar analysis. Start by identifying the basic shape of the graph. Focus on one period. Here's the y-axis. How far do I go? Let's see. Right here is when the graph starts repeating again. Well, I recognize that. That's the ghost. This is reflected cosine. Okay, how about the amplitude? Well, that's pretty easy to see. The distance from the midline up to the top is clearly 4. The amplitude is 4. Well, that means that the value of a in my equation must be negative 4. The negative because of the reflection, the 4 because of the amplitude. How about the period? Well, we already marked out one period here. Let's see, I need to know this value. The only one I was given on the x-axis is 5 pi. That's half of the period. So of course that means that the full period out here must be 10 pi. I must be counting by 2.5 pi. 2.5, 5, 7.5, and then 10 pi out here. So my period is 10 pi. Well, I can use the period to figure out the b. Remember our little formula, p equals 2 pi over b? I can rearrange that formula to solve for b. I'll clear the fractions, and then I'll divide both sides by p. And I end up with a very similar formula, b equals 2 pi over p. Use the original formula if you want to find the period. Use this formula if you want to find the b. Well, that's what I want to do in my problem. I want to know what b is. According to my new formula, b is 2 pi divided by the period. The pi's cancel. I've got some reducing going on, and I end up here with b equals 1/5. Well, I have everything I need now to write down this equation. The equation would be y equals negative 4, there's my a, cosine, we knew it was a cosine graph, of 1/5 x. Y equals a cosine bx. There's the equation. If you wanted to, you could graph that equation in your graphing calculator to verify that it draws this picture, and it will. Okay, let's look at a second one. Again, focus on one period, starting at the y-axis here. How far until I repeat? Looks like I get to right here. What have I just drawn in? Well, that is our regular sine function. And then what's the amplitude? Well, the only number marked here is negative 40, but of course that means this must be positive 40. And I can see that that's the distance from the middle to the top. It is 40. The amplitude is 40. Since I don't have any reflection going on, that means that the a value is also 40. How about the period? Well, this is a little tricky. The only marking I'm given on the x-axis is right here, 5/2, 2.5. That is not where the period ends, though. The period ends at the marking before that, so I need to figure out what I'm counting by. Let's see, I have 1, 2, 3, 4, 5 spaces here to get to the 5/2. So I think I need to take that 5/2 and divide it into 5 to figure out what I'm counting by. Dividing by 5 is the same as multiplying by 1/5. The 5's cancel, and I'm left with 1/2. So I must be counting here by 1/2. 1/2, 1, 3/2, or 1.5, 2, 2.5, etc. Okay, so I had to do a little bit of work, but it's obvious now that the period is 2. Well, I can use that to get my b value. Using our new formula, the b is 2 pi divided by the period, which of course simplifies to be pi. My b value is pi. Now I can write down the final equation. I would have y equals my a. This is a sine function of pi x. Y equals a sine bx. Here is the equation of that graph. Once you understand the concepts, you can work these problems pretty quickly. Thanks for watching.